All right, we will take a look at a little bit about the basic factoring. Basic factoring review. So let's take a look at this particular problem. We want to factor ax plus 5x. Now it's absolutely important to understand what the question asking you. Factor, what's that mean? We want to make these things becomes a product. Something times something. A factor times another factor. So if I take a look at ax plus 5x, how many terms do we have here? We have two terms. Terms are separated by a plus or minus. So ax is a term, and 5x is also another term. If I try to make this becomes one single term, something times something, I need to take a look at the GCF from both of these terms. What do they have in common? X would be in common. So I am going to factor out the x. Make it becomes x times something. Now once we factor out the x, then I have x times, what is the leftover? The leftover would be the original terms divided by the GCF plus 5x, which is the original terms, divided by the GCF. Now we can easily verify this by reversing the process. If we distribute the x back into the parentheses, then we have x times the first fraction, then you see the x cancel out, we will get the ax back. Plus, distribute the x into the second fraction, and then we have the x and the x in the bottom cancel out, so we got back the 5x. So the leftover is always the original terms divided by the GCF. After this, we can simplify, so we will get x times parentheses a plus 5. Everybody happy? Let's see another one. I want to factor x cubed plus 7x squared. How many terms do we have? Two terms. What do they have in common? What is the GCF? X squared. So I'm going to factor out the x squared. And the leftover would be x cubed over x squared, the original term, divided by the GCF, plus 7x squared divided by x squared. So now let's simplify that. So what would that become? It would be x squared times x cubed divided by x squared. What do we have? X plus 7x squared divided by x squared. What do we have? We have 7. Let's see another one. Okay. Now in the previous one, actually the x squared and x squared cancel out, right? So looks like, we have a 1 left, but since I have a 7 times 1, so I actually don't even bother to write 7 times 1. I just simply cancel out the x squared. All right, let's take a look at the next one. I have the 6x cubed y squared plus 9xy. I want to factor this. So the question asking me to make it becomes something times something. So how many terms do we have? We have 2 terms. What do they have in common? Well, let's do it step by step. This time is a little bit more complicated. The number 6 and 9, what do they have in common? 3 is the GCF. So I have 3. How about the x? X cubed and x, what do they have in common? X. Okay. Y squared and y, what do they have in common? Y. So together, 3xy would be my GCF. And I'm going to factor out the GCF, the 3xy. So what would be the leftover? It would be the original term divided by 3xy plus original term 9xy divided by 3xy. So let's see what is the leftover. I have the 3xy times open parenthesis. In the first term, 6 divided by 3, what would that be? 2. X cubed divided by x, what would that be? X squared. Y squared divided by y, what would that be? What is y squared divided by y? Y. That's it. Plus 9 divided by 3. I have 3. X divided by x. What would be x divided by x? Would that be 1? Would that be x? Would that be 0? How many of you think is 1? How many of you think is x? And how many of you think is 0? Okay. The answer would be 1. Now be very careful. Sometimes it's easier to confuse ourselves because when we say x there, oh, let's cancel them out. Now cancel is an ambiguous term. Sometimes we have 5 minus 5. We also say, oh, let's cancel them out. When you have 5 minus 5, the answer would be 0. Now, so be very careful. Use the proper terminology to help you to avoid any future trouble. X divided by x. You have the numerator and the denominator exactly the same. When you divide, what do you get? You have 1. Right? You have 5 pizza. We have the pizza party. We order 5 pizza. You share with 5 people. Each one will get how many? 1. Right? 5 divided by 5 is 1, not x, not 0. Although sometimes we say, oh, let's cancel them out. In this case, when we say cancel them out, we are referring to reducing in the fraction. X divided by x indeed is 1. How about y divided by y? Is also 1. Is it necessary to write down 311? No, we are not getting information. It's 3 times 1 times 1. But is it necessary to write 3 times 1 times 1? What is 3 times 1 times 1? It's just 3. So why bother? So it would be just simply 3. And that would be my final answer. I make it become something times something. Okay? Now again, the factor is my question. Absolutely important to write this down clearly. Let's see another one. Uh-oh, getting a little bit more fun. How many terms do we have? We have 3 terms. Terms are separated by a plus or minus. So let's do it step by step. Let's see if there is any common factor. 15, 9, and 12. What do they have in common? 3. Good. So I take out the 3, or I should say factor out the 3. How about the variable x? X cubed, x to the 4th, x squared. What do they have in common? X squared. How about the variable y? Y to the 6th, y to the 4th, y to the 5th. What do they have in common? Y to the 4th. We look for the smallest exponent, right? So that is the GCF. So I'm going to factor out the GCF. So the leftover would be the original term divided by the GCF minus the original term divided by the GCF plus the original term divided by the GCF. So what would that become? Let's say 3x squared y to the 4th times, open parenthesis. Let's see the first term. 15 divided by 3, 5. X cubed divided by x squared, x. Y to the 6th divided by y to the 4th, y squared. Good. Minus 9 divided by 3, 3. X to the 4th divided by x squared, x squared. Y to the 4th divided by y to the 4th, what would that be? It's 1, right? They are the same. So be careful when you say cancel out. We are talking about we have 1 left. But do we need to write down that 1? No, right? Because we have 3x squared times 1. And then the last term plus 12 divided by 3, we have 4. X squared divided by x squared, 1. Do we need to write it down? No. Y to the 5th divided by y to the 4th, that would be just y. So that's it. That would be my final answer. I make it becomes something times something. So far so good? Right? Okay, let's see another one. Oops, sorry. We want to factor out the 6x squared plus 3x. Oh, that one should be relatively simple. How many terms do we have? We have 2 terms. And what do they have in common? What is the GCF? 3x, right? The number is 3, and then x squared and x, the GCF would be x. So together, 3x would be my GCF. What is the leftover? I have the original one divided by 3x plus the original one divided by 3x. So what will we have left? We have 3x times, open parenthesis, 6x squared divided by 3x. What would that be? That would be 2x plus what? Plus 1. Right? 3x divided by 3x is 1. This time, do I need to write down the 1? Yes, absolutely. Now, unlike the previous situation, because I have some other factor, so I don't bother. Now, be very careful when we say factor the GCF. We should always say factor. That's the proper terminology. Sometimes we say, or people say, take it out. Take out the 3x. Yes, we like take out. But if you keep saying they take out, take away, sometimes it could be ambiguous. Because when we say minus, 5 minus 5, we can also say 5 take away 5. Then what will be the answer? It would be 0. So sometimes when we're using some ambiguous terminology, it would lead us to future trouble. So be careful. This time, we are not exactly taking out, or when we talk about take out, we are actually talking about factoring. So it's better for you to keep saying the right thing. We factor out the 3x. We factor out the GCF. And once we factor out the GCF, what is the leftover? The leftover would be the original terms divided by the GCF. So in this case, we have 3x divided by 3x. That's why we have 1 left. It's not, we got nothing left. Oh, 3x take away 3x. That's nothing. Right? Sometimes students would make this careless mistake. How about this one? I want to factor out the negative 4x plus 12. Well, what do they have in common? If I just take a look at the number 4 and the 12, what do they have in common? More than 2, 4 would be in common. Now, but it's also nice if you see the negative in the front. We want to factor out the negative also. so that whatever inside the parentheses, we will begin with a positive number. So this time, let's try to factor out the negative 4. What would be the leftover? Times the original divided by negative 4 plus the original 12 divided by negative 4. So what would that equals to? We have a negative 4 times negative 4x divided by negative 4. What would that be? It would be just x. Plus 12 divided by negative 4. What do we get? Negative 3. So we plus a negative 3. That really means there's minus 3. So we got the negative 4 times parenthesis x minus 3. Another one. How many terms do we have? How many terms? 2 terms, right? And 5 and 40, what do they have in common? 5. And we also like to factor the negative also, right? Do we have any variable in common? Nope. So negative 5 is what we are going to factor out. And the leftover would be negative 5y squared divided by negative 5 plus 40x divided by negative 5. So let's see what is the leftover. Negative 5 times open parenthesis negative 5y squared divided by negative 5. What would that be? Y squared. Okay. Sometimes we would say the negative 5, oh, they cancel out. Right? Indeed. In this case, we reduce, we divide, we got 1 left. So it's 1y squared. That means y squared. Minus, because plus a negative. 40 divided by 5, 8. And then I have x left. So far so good? Let's take a look at one more. Oops. What happened? Okay, here. Let's see one more. How many terms do we have? We have 2 terms, right? Negative ax squared minus 12x. And we want to factor out them. So what do they have in common? Just 4? Just 4x? A little bit more. We want to factor out the negative also. We want to factor out the negative 4x. So let's see what is the leftover. Original terms, ax squared divided by negative 4x minus 12x divided by the negative 4x. So let's see what do we have left. Negative 4x times open parenthesis negative divided by negative positive, right? 8x squared divided by 4x, we have 2x. Again, minus a negative becomes plus. 12x divided by 4x, that would be 3. So we make it becomes a factor form. We have something times something. Everybody happy? Okay. Now remember, the question is absolutely important. Sometimes some students just omit the question. They just do something and they got the right answer. But then later on, they don't even understand what that really means. Sometimes we go backward, sometimes we go forward, depending on what the question asking us. Sad to see sometimes students handling the factor problem. They factor them out, but then afterward, they distribute again because they don't know where to stop or what the question looking for. Factor means we want to make it becomes a product. Make it becomes something times something. All right? Everybody happy?